Hey everybody, this is Jason Kent with Sequence Security and Awareness Training. My name is Jason. As I said, I'm the hacker in residence here at Sequence Security, and today we're going to be discussing APIs. The goal of this training is to understand what an API is and how to test your APIs. Eventually, you'll be able to identify flaws in the APIs that you have in your environment and suggest steps to mitigate those flaws to make your APIs safer. In this video, we're only going to talk about an introduction to API security training. There will be subsequent videos that allow for you to learn more about API security as time goes on. For the video series, we're planning on a series of trainings that allow for you to understand what an API is, instrument yourself with a lab so that you can test your APIs, understand how finding APIs is important, and different kinds of recon techniques that you can perform in order to look for APIs for your organization. We're going to be testing APIs with various different tools, as well as understanding indicators of compromise within your APIs. Finally, we're going to show you how to mitigate some of the attacks against the APIs your organization might have. In this video, an introduction to API security training, we're going to talk about what an API is, the threats against those APIs. We're going to go through the OWASP API top 10, and then I'll wrap it all up and give you some next steps to prepare you for the next video, which is going to have interactive lessons in it. If at all during this series you'd like to reach out to me, that would be great. My name, as I said, is Jason Kent, and I work for Sequence Security. You can email me at jason.kent@sequence.ai. I also have a Twitter handle. I'm CyberNSA. I'm not NSA Cyber. I'm pretty active with the OWASP community, and I work with Hackers for Charity. If you'd like to learn more about that organization, just let me know. We protect web applications and endpoints from automated attacks here at Sequence Security, and I'm a fairly well-known researcher that found a flaw in Chamberlain's MyQ program, allowing me to open my garage and a friend of mine's garage, and this allowed for me to have a much deeper understanding of how APIs work and the kinds of tests that you should perform against them. This course was really developed as a result of what I'm seeing our customers go through on a day-to-day basis. So this isn't built off of theoretical knowledge or knowledge of APIs in general. These are specific attacks that are happening across the industry, and I'd like to get more people aware of them and help them understand how they can mitigate these things. You're going to hear mention the company that I work for, and in fact, these videos are hosted on our company channel. This all comes out of a very generous donation of time and resources for me to put this class together as an OWASP class, and now I'm carrying that forward and allowing anyone to access this information for free. So if you want to look up my boss, his name's Shreyans Mehta. He's a great guy, and he's the one that's allowing for this to happen. Quick disclaimer, corporatees, lawyers, whatever it is that you want to say, please do not use these techniques against any organization you don't have permission to. And remember, that permission has to come from someone that can grant you that permission. If your buddy Joe works in the mailroom and says, yeah, go ahead and hack our website, I don't think that's good enough. Please don't go out and start hacking APIs that you have no business attacking. Let's make sure that we understand what we're doing before we go out there and start probing these things. So what is an API? Well, I mean, there's a textbook definition of this, right? It's an application programming interface, and it allows interactions between software intermediaries. But realistically, it's a simple data exchange. It's a lot easier to write a web application if you don't have to keep rewriting the framework of how the data is going to be displayed, but rather just write the framework of how to get the data. Then you just move the data back and forth and put it in the fields that you need to. And this allows for you to have kind of cross-platform understanding from your web applications, your mobile applications, and any other ways that you may be plugging into your environment. Why is this so important? Why are we even talking about APIs? Well, as we all know, we're undergoing the rapid digitization of commerce. We're seeing more and more organizations move to a digital footprint rather than a physical footprint for what they're doing. We're calling this the digital transformation. But realistically, what's happening is we're doing more commerce faster on these platforms than you would be doing if you had to be performing business transactions face to face or over fax or mail or whatever that is. So, what's happening is we're building this framework layer underneath our applications that allow for things to just plug into it. So, if I have a web application, if I have a mobile application that my users are using, they're going to be going through basically the same infrastructure. And even those third parties that are going to hook into us are using that same infrastructure to allow for the services that you put out there for your customers to exist. Some examples of where you might see API integrations: mobile applications, web applications, data collection applications, and integration points. You'll see things like if this, then that type of integrations that can be built. Social media aggregation is one of those places where if I want to tell the world something, I type it into one place and hit go and it tweets it. It puts my LinkedIn profile article out there. It does Facebook, etc. And all of those integrations come off of a single point. We're also seeing API examples in things like SIM and patch management solutions allow for you to accelerate your vuln management program or accelerate your log analysis for your organization. We're seeing APIs used for mobile and web at an increasing rate. We see it happen at every one of the organizations that we work with. There's more and more APIs out there. There's more and more APIs that need to be protected. And what we're seeing is the rate of adaptation of APIs does not meet the rate of security testing that's going along with it. There's some direct impacts related to API-related attacks. In this slide, I talk about a direct impact of almost $4 billion in ATO costs. ATO is account takeover. It's just simply an attacker looking at the login endpoints for your organization, attacking those endpoints either with simple brute force password attacks or something more sophisticated and taking over those accounts. And what we're seeing is in the retail space, every dollar of fraud loss is almost $3 of cost that goes along with it. The indirect impacts are huge, right? $137 billion in 2019 lost in customer sales because of things like lack of trust. After you have one bad experience, you're 33% more likely to move on to a different organization and use their services. There's a lot of competition out there. And we're seeing when you try to acquire a new customer acquisition costs are going up because this competition makes it easier and easier for people to switch around. Retention rates drop tremendously when you have things like a breach go on. Those losses are usually because APIs make the attacks a lot easier. I can go find your API pretty easily. Either it's in your mobile application, which that I can just take apart and find the API endpoints. I can look at transactions through an intercept proxy and figure out where the APIs are there. So just discovering these APIs is something that's a fairly simple task. And then the attacks that go on against the APIs could be a framework attack where I just simply download something like OpenBullet and I apply a config file for your organization and let it do the attacking. It'll find the proxy networks for me, credential sets, all that kind of stuff. And so making attacks against an API environment is extremely simple. And when the attack execution phase is going on, and I'm actually executing the attack against an organization or if someone is attacking you, all of these toolkits that are out there have just about everything that you would need associated with them. And the APIs actually facilitate the attack because they're meant to run at a much higher speed. So the attackers know this and know how much pressure they can apply. Why is it hard to defend against APIs? Well, basically it's because they're stateless in nature. I send you a transaction. All of the parts of the transaction that are needed are included in the request. So there's not a lot of hanging around and seeing one session have a whole bunch of traffic on it. And in fact, if you see one session doing a bunch of different things, it's very much an indicator of compromise, an indicator that somebody's attacking. The full transaction is there. I don't have to have a client or agent. And in fact, if I want to make an API call from the command line, I can. In this case, you can see I'm making a request out to an organization, and basically I'm authenticating to them. It's TP-Link Cloud. This is a CASA camera platform that I was testing against. And in fact, if you look in our blog series, you'll see I found some flaws in this and did a responsible disclosure with them and had them go fix a problem that they had with their platform. But you can see here, I'm simply on the command line issuing a curl request. So I throw some headers in it, username and password, and hit enter. Anybody that's listening to this video or watching this video that has an understanding of how you can script things or use Python to write a script, you can see all I need is a set of usernames and passwords, maybe an email, and I can get some pretty interesting authentication tokens. I can get understanding of account IDs, etc., just off this one API call. So authentication is really important in APIs. Standard HTTP authentication methods apply, but we're not seeing the verbosity that we should. We're not seeing people take this to the next level. Base 64 encoded username and password is how CASA was passing data around. And that's not a great idea, right? API keys typically are generated for a single entity, but sometimes they're generated for multi-use. So that key can get compromised and be used anywhere that you might use it. Also, sometimes developers utilize their comments to store API keys in case they need to come back later or they've forgotten where they put it or whatever. And so sometimes you find those API keys in places that you shouldn't. Protect the key. That's a really important thing. And just so that you understand, I can make API curl requests to just about anything. And here is a pretty good or simple thing that you can look at. A lot of people do things like appliances or network equipment that allow for you to programmatically manage things. In order for these APIs to be secure, we shouldn't be passing anything in HTTP that contains things like credentials or passing information that might be extremely sensitive like certificates. All right, so let's dig into the sorts of things that we might have to deal with if we're trying to protect an API. OWASP is the Open Web Application Security Project. And OWASP is an organization that really focuses on application security. I've been a member for quite some time. I've worked for several organizations that have been members. It's a great organization that likes to spread the word about application security. There's a top 10 that goes along with APIs, just like there is with web applications. And so here you can see the top 10 as it lays out from the 2019 version. What we're going to do is cover each one of these to a little bit of detail, but if you want to read more, you can go out to owasp.org and look at the API security project. So the first one is broken object level authorization. This might look like an early 2000s kind of problem, and realistically it is. I often tell people that in API security, we're just repeating the mistakes that we made in application security. For some reason, we didn't learn these lessons, but eventually this stuff will get out there and more people will look at it. Broken object level authorization just simply means, am I authorized to look at that particular resource? And so what can come out of this is something that we call insecure direct object referencing. But basically, this is authorization of what I can do. Can I delete this? Can I add this? Can I view it? What am I allowed to do with an object at some point in the application. Prevention for this is just simply a policy or hierarchy mechanism that allows for authorized people to see things or not see things, right? Authorized users can touch their own profile, for instance, or their own pictures, but they can't edit someone else's profile or their pictures. Authorization mechanisms need to be logged. We have to have a good understanding that you have access to perform this thing. We want to use random and unpredictable values in these, because if it's a predictable value, I can predict the next one and iterate through things. And you'll get to see that further down the line when we go into labs. And we also want to test authorization mechanisms and make sure that we do some regression testing and testing that we've found flaws in the past, because sometimes these bubble right back up again. Broken user authentication is often an authentication method that was implemented incorrectly. Maybe I can fake out the user that I am, or maybe I can fake out the client that I'm using and break all of the pieces in the authentication realm and allow myself access to things. It doesn't necessarily have to be username and passwords. A lot of times we see things like SMS verification tokens, which can also be brute forced and allow people past the APIs. Make sure you know where things are going in the API, understand the flows. Really, what we're trying to say here is you have to threat model each one of these items and understand what's going to happen if you're outside of the threat model. Excessive data exposure. This is one that I did the responsible disclosure with CASA on. They actually had an API call that would tell you bad username or bad password. And it doesn't take very long to go through a few of these iterations to understand, all right, I can figure out what good usernames look like on this system, and then start attempting passwords, because it's going to tell me if the password's good or bad. Prevention for this, and you're going to see this a lot, is never rely on client side, right? The client doesn't necessarily have to run your code. They don't have to do the things you want. They're going to send requests in the way they want. So you always want to ask yourself, who's consuming this data before you expose a new endpoint, and have a good understanding of what happens if it gets out. Lack of resources and rate limiting really often comes down to denial of service, but oftentimes automated attacks are just using all of the resources that they can. If they're sending 40 or 50 transactions a second trying to brute force a password, and your systems allow them to do that, basically you've instrumented them to do whatever it is that they'd like. Now, granted, you didn't intend that, right? You're probably intending to have your application work faster. But what can be the result of that is if you're resource limiting or rate limiting, your clients aren't going to be able to overtake your environment. But if you aren't resource limiting or rate limiting, an attacker might be able to do that. Having a good understanding of limits in your environment is a great idea, and is something that you should teach your QA organization to understand. Function level authorization has to do with hierarchies or groups of what authorization that you might have. So what I'm saying here is I may not be authorized to edit a profile that isn't mine, but an administrator is. So what I can do is up-level myself to become the administrator, and now I have authorization on a specific object, and you didn't protect me from going up in a vertical privilege escalation, for instance. So we have to have a good understanding of what functions exist that feed other mechanisms in the systems. Make sure that you do a good API review. Is an admin allowed to do things here? And if they are, can I become an admin? Is a new user allowed to do something? And if so, how do I create one? There's a bunch of things like that that you have to go through. mass assignment is a really interesting vulnerability to really look at. But basically, all mass assignment is it allows you to guess an object's properties or look at API endpoints and send in property payloads that you may or may not have learned through some reconnaissance event. And what I mean by this is if we have an understanding that we're going to have, I don't know, a username, a password, maybe in a profile we'll see something like an age. But then we have an understanding that when I set up an account, I only touch like username, password, age, because the credit balance is something that's going to happen on the back end. So then you have to kind of ask yourself the question, well, if I know about that JSON object, if I know about that data that I could send in, can I just send in a credit balance on that user creation step? And those are the kinds of things where I might be able to use some JSON object that's permitted inside of a data stream somewhere else and assign that to myself or many others. There's a lot of prevention mechanisms that go around this, but having an understanding of input is really important. Sanitization of input is one of those things that's often missed. Security misconfiguration, it's almost always something like a default was left on or somebody didn't go turn something off. But it could very well be that it was a choice that was made in a non-production environment that moved to a production environment. And so you can see things like basic authorization that gets set up for APIs, oftentimes in like a staging environment, that moves forward into the production environment. So here you can see I'm making a curl request and I'm sticking a basic auth header inside of it. And the reason why basic auth isn't that great, anybody that has Burp installed, I'll pause here for a second, or you should pause and grab this short little bit of base 64 encrypted text and perhaps move it into Burp's decoder section and decode it as base 64. You'll see what it is. And so one of those things that you really have to look for when you're testing authentication and authorization routines is, can I do basic auth here? Not just is it available or not available, or it's not the option that's currently selected, but can I do it anyway? Security misconfiguration prevention often comes down to the way that you do build outs. If you're in a DevOps environment and you're building out servers really quickly, having a properly locked down environment as the beginning is going to spread all over the organization as they push things like hardened servers out. Review your configurations, review your permissions, review your settings, have a good understanding of what's going on out there. I've walked into several organizations in my time as a penetration tester where I would look at their AWS environment, see that they had, very nice mechanisms for understanding who's logged in and where they've logged in, but really no mechanisms for which servers can communicate to each other. And I've even seen places where they've decommissioned devices that had permissions everywhere, and the IP address got reused for another server. So if you think about that, if I get shell on server A that has an IP address that used to be allowed to touch server B, I may now be able to get onto server B, right? And those are the kinds of things that you have to have an understanding of and have a good testing mechanism for. Number 8 here is injection. Most people call it SQL injection, but it's any kind of injection that you could put in. As you can see in the example here, I'm going to go touch some device and send it its power down shell command. That sounds like a really terrible thing, right? Just suddenly having your server shut off from the curl request into some API that's out there. I think this is so important that I put it all by itself on a single slide. Don't trust the user data, right? Back in the early 2000s, my wife was a web developer, and she was developing an application, and I said something to her about, well, can't I bypass that? And she said, well, I'm checking this in JavaScript. And I said, well, what if I don't want to run your JavaScript? I don't want to run your code. I want to run my code. And that allows for me to do things that are malicious. So doing my own thing and not being like one of the others means that I'm going to be sending information you should not trust. Do not trust user-provided data. You got to perform validations, filter, sanitize, switch characters. You got to do all the things that you can to make it so that if somebody is attempting to log in with, I don't know, an injected username or an injected password, that you switch all that stuff out and it just looks like a bad username and bad password. And hopefully you give them an error message, something to the effect of, you can't log in right now. Improper asset management. The number of clients that I have that have more than one version API endpoints is 100%. Everyone has multiple versions of API endpoints that have things like different authentication services behind them, or different functionality that they included in later versions of an application or something like that. I just was reading a client message the other day that said our V11 endpoint is being attacked. Our V11 endpoint, right? And when you look at their organization, V11 isn't the highest number and it's not the only one that's running. Inventory all of your API hosts. Know what you have out there and understand that you have documentation on your APIs perhaps. And maybe that documentation is completely public. Maybe you don't want that. And so have a good understanding of everything around your API as far as reconnaissance for an attacker might go needs to be secured in some way. And finally, logging and monitoring. Just like in web applications, you should be logging specific types of triggers. Things like authentication success or authentication failures. If you see a single user having authentication failures from 70 different IP addresses, you have a pretty good understanding that you have an attacker attempting to use a proxy network to log in with a bunch of different IP addresses and a bunch of different usernames. So that logging and monitoring is going to trigger you right away to say, I have an attack going on. What can we do to mitigate this attack? Insufficient logging and monitoring prevention. Well, guess what? Have sufficient logging and monitoring. It's pretty simple. Lots of logging is going to mean you're going to have lots of logs, so you got to be ready for that. But being able to search through those logs and having a good SIM, for instance, may make it so that you can aggregate events and understand what's going on. Here at Sequence, we look at attacks in 4 categories of pillars that hold the attack up. Those pillars are tools, infrastructure, credentials, and behavior. And understanding that automated tools are going to be out there managing attacks against you. Credentials are easily sourced, regularly refreshed, and so much credential reuse out there means that a credential set that works for somewhere else might work on you. Infrastructure allows the end user to look like they're coming from everywhere. These attackers will attack you from 1 million different IP addresses and send you 15 million transactions. And that's just not numbers I'm making up. That comes from clients. Behavior, they're going to react when they're blocked, right? If they're being blocked or if something changes suddenly, attackers change very rapidly with that stuff. All right, so wrapping up a little bit, APIs are becoming the backbone, if not already are the backbone of our economy. This API attack surface grows constantly at a very steady rate every day. Many API security issues are security issues that we've already solved. Like I said before, application security issues from the past are leaking forward into API security issues, and it seems like it's fairly easy to take care of these things. Protecting APIs has become a crucial effort for most organizations, especially if you're in the middle of a digital transformation. So I really thank you for coming to this thing and checking out the video. If you would like, we're going to have subsequent videos published, and we're going to be taking you through ways to find your APIs, test them, and mitigate the risks that you find. In order to move forward with those exercises, you're going to need an intercept proxy. I'm going to show you how to do proxy intercept for various different types of things like mobile application proxy intercept, web application, even off of the command line using curl. And I'll instrument you with a really nice tool called the APK tool that was developed to allow for you to take apart Android applications and find the API endpoints that are inside of them. I put that in a Docker image. It's kind of a large image. I apologize. I really wanted it to be functional because later on you're going to be scripting attacks inside of that image, and I needed some Python libraries, etc. So please don't get too down on me for the image size. Grab it, and once you have Docker Desktop installed, you'll be able to pull it by issuing that command docker pull JSON sequence and then the APK lab is the one that you want. Like I said, if you have any questions, please contact me. You can put some comments down in the comments section, or you can just shoot me an email, and I'm happy to answer it. Again, thank you for your time.